Welcome to another video from math115.com. Today we're talking about mean. So these are going to be all the different types of mean that you need to know in this class. So mean is obviously average. So let's start off with a simple one. You know the common example of a coin flip, right? You have X represents the number of heads that appear on two coin flips. And so X and a little f of X column here. So you have 0 heads, 1 head, or 2 head. And so what you know is that if you remember, the probability of this is 0.25, 0.5, and 0.25. So this is a standard variable with a PMF right here. And you know that this is a PMF because there's a finite number of possibilities. There's only 3 possibilities, and these 3 numbers right here add up to 1.0. So this is a simple finite example. So mean, you already know the standard expected value, right? So the expected value for this, you multiply across 0, 0.5, and then 2 times 0.25 is 0.5 as well. So you're going to get 1. So we've already done something like this, but the reason why I brought this up was because there's something special about the coin flip example. The coin flip example is a specific kind of distribution. This is a finite random variable, but it's a special kind. It's a binomial random variable, or binomial distribution. And so the reason why this is a binomial distribution is because it satisfies the 2 requirements. One, it must only have 2 possibilities, so you can either have a head or a tail, and those are the only 2 possibilities. And 2, they must be independent of each other. So the head flip is independent of the tail flip because it doesn't have any effect on the outcome. So it does satisfy those 2 possibilities, so therefore there's a certain formula that we can use to solve binomial random variable means. So the expected value for a binomial random variable is n times p. So if you have one coin flip, right, one trial, so your n will be the number of trials. So if you have 1 trial, and the probability of getting a head or a tail, well, the heads is 50%, you put in 50% for the heads, and you'll get 0.5. But if you wanted to get this answer, well, this would be 2 coin flips, because this is just 1 coin flip. Now, if you want to do 2 coin flips, do expected value. Again, your trials would be 2 this time, and you do the same probability, 0.5, and you would get the 1.0 expected value that we got here. So this particular experiment was the 2 coin flip one, and therefore corresponds with the binomial formula that requires the 2 coin flips. So the other means that we need to go over are the means for continuous random variables. So the continuous random variables, we've talked about 2 types of distributions so far. So let's start with the uniform ones. So the uniform distribution, and remember, this side is continuous, and that side over there was finite. So I'll go ahead and put finite right here. So under the continuous section, uniform random variables, they have their own expected value formula. So the expected value of a uniform random variable is A plus B divided by 2. So going back to our standard example where we go 0 to 10, right, you have a uniform random variable, a uniform distribution with a height 1 to 10, right? And so that's 10. What you would do here is that A represents the very beginning point, B represents the very end point, so you do 0 plus 10 divided by 2, and you get 5, which is the exact halfway point. Obviously, your actual problems will be a little bit more difficult. Just remember that this is very important. 0 is the very beginning point of your distribution, and A was the beginning point of the distribution, B is the very end point of your distribution. So even when they ask you questions like, what is the probability 7 less than or equal to X less than or equal to 9, the mean is still going to be 5 because you're only caring about the 0 and the 10. The 0 represents A, the 10 represents B. The 7 and the 9, even if they draw it on the graph like this, does not have any effect on A or B. So let's go to the other one. We talked about exponential distributions. And the only thing you really need to know for exponential distributions is this bar. Alpha is the same thing as mean, is the same thing as expected value, is the same thing as average, is the same thing as the little mu symbol that they might give you, and is also the same thing as, if you see this, it's x bar is also the same thing as mean. You probably won't be seeing this x bar very much in this class, but in case you do, now you know. And that's really all you need to know. But there is one trick that they can do with exponential random variables, and here's that real trick right there. So let's say you have 0.25 e to the negative x, negative 0.25, sorry, x. So what if you're presented with a situation like that, and you're asked, so this is all they give you, and they tell you that that's little f of x, and they're asking you, what is alpha? So alpha equals question mark. Right, so this is the only information they give you, and they're asking you what is alpha. Well, here's what you need to be able to recognize. The PDF formula for an exponential random variable is 1 over alpha e to the negative x over alpha, right there, right? And the reason why we're looking at the PDF formula is because they specifically gave us a little f of x. So that little f of x is referring to the PDF formula. So what they're essentially saying is that this formula right here is in the same format as this formula right here. The only problem is that they've given us a decimal here, and this is supposed to be a fraction. So alpha is not 0.25. Don't make that mistake. Because this needs to be first converted into a fraction before you can understand what alpha is. Because alpha is not the whole fraction, it's only the denominator of the fraction. So we need to first find the fraction, and the fraction has to be 1 over something. So we're looking for a fraction that represents 0.25. Well, we know that 1 over 4 is equal to 0.25. So what if we replace all the 0.25s with 1 over 4? Let's see what happens. So down here you're going to get 1 over 4 e to the negative x over 4. So all I did was rewrite this equation with 1 over 4 as the 0.25 instead of 0.25. And so that's equal to little f of x. Now it's much easier to identify what the alpha is. Again, the alpha is the denominator in the PDF equation. So alpha is equal to 4, not 0.25. So that's basically all the basic tricks that they can throw at you for when it comes to mean. Great.